Today we discuss about the center of gravity of solid bodies. So, center of gravity of solid bodies. So, as I have said earlier, that centroid is the center of geometrical center of a shape, while center of gravity is the center of mass or center of weight of a three-dimensional body. So here in this center of gravity of solid bodies, as we calculate the centroid by incorporating the area of the figure, here we consider the volume of the body. So for x bar, this is summation Vx upon summation V, where V is the volume, of body. So y bar is summation Vy of summation V. So here in place of centroid, in the centroid, here in place of volume, there will be area, and here also area. But in center of gravity, volume is used because it is a three-dimensional body which has the weight or mass due to the density of the material by which it is made. So by multiplying volume into density, is mass is obtained, and here like x bar is equal to V1x1 plus V2x2 plus V3x3 and so on, and V1 plus V2 plus V3 and so on. So here by multiplying by density, x bar is equal to V1 x1 into rho plus V2 x2 into rho plus V3 x3 into rho. If all the body's parts are made by similar material, then it will give you the mass. And as we know, center of gravity is the center of weight. So V1 x1 rho into g plus V2 x2 rho into g plus V3 x3 rho into g plus, and this is V into rho into g plus V2 into rho into g plus V3 rho into g. So this is x bar is equal to W1 x1 plus W2 x2 plus W3 x3 divided by W1 plus W2 plus W3. So W1, W2, W3 are the weights of the body. So in this formula, x bar is summation W x upon summation W. So this is the weight center, or if we eliminate g from the numerator and denominator, then it will become mass, so mass center. Or if rho and g are the same for all the parts, so from denominator and numerator it will cancel out, and only remaining is v1x1 plus v2x2 plus v3x3 and v1 plus v2 plus v3. So we can find out the center of gravity by putting the volume of the body, or by considering only the volumes of the bodies. Or similarly, y1 is equal to summation w y upon summation w. So like this we can find out the center of gravity of solid bodies. Now center of gravity of some particular well-known bodies. So first of all, we take cylinder. So this is a cylinder. This is the axis of symmetry or axis of rotation, and this is radius of the cylinder, and from here to here is height of the cylinder. So now volume is pi r square h is the volume of the cylinder, and center of gravity is x bar is 0, because this is the axis of symmetry or axis of rotation. So this is one reference line. From this reference line, x bar is 0 because it is lying over it. And second reference line is this. So from here to here, this is y bar. So y bar is h by 2 for a cylinder. So x bar is 0 and y bar is h by 2 for a cylinder. Now the sphere. For a sphere is, this is a sphere, and these are the symmetrical axes of a sphere or axis of rotations of a sphere. So these are as taken reference line as in the case of circle. So the centroid or center of gravity of this sphere will lie over this center. Suppose this is R, so volume of this sphere is 4 by 3 pi r cube. 4 by 3 pi r cube is the volume, and x bar is equal to y bar is equal to 0 if these are the reference lines. Now hemisphere. Now this is a hemisphere. This is a hemisphere. So this is the symmetrical axis or line of symmetry about which it is symmetric. So this is y-axis and this is other one line of reference. So the centroid of this hemisphere will lie over this line, and it is lying at a distance from this line here, and this is equal to 3r by 8. In case of a semicircle, it was 4r by 3 pi for the centroid, but in case of a hemisphere, it is 3r by 8. So don't confuse by seeing only the shape. It is a hemisphere, and in case of hemisphere, the centroid will lie at a distance from x-axis as 3r by 8. So volume of this hemisphere is 1 by 2 of sphere. So sphere volume is 4 by 3 pi r cube. So 1 by 2 of this is 2 by 3 pi r cube. So this is the volume of hemisphere, and center of gravity, for center of gravity x bar is 0 because it is lying over this line of symmetry, and y bar is 3r by 8. So as in the case of a semicircle, if the orientation of this hemisphere is changed like this, then in this case x bar is 3r by 8 and y bar is 0, because now the line of symmetry is this. So centroid will lie over this, and from here it will be at 3r by 8 distance this side. So x bar is 3r by 8 and y bar is 0. So as the orientation is changed, the value x bar and y bar will be interchanged. So there is no problem of, as similar as in case of semicircle. Now the cone. In case of a cone, so this is a cone. So this is a cone. So this is the height of the cone. This is height of the cone, and this is r. Now volume of the cone is 1 by 3 pi r square h, and this is seems like a triangle. So it is symmetric about this line. So centroid will lie over this line. So x bar will be equal to 0. And here, in case of cone, second reference line is this. So from this line, this is the distance. The centroid will lie over this. So this is the distance y bar. So this will be h by 4. In case of cone, y bar is h by 4. Here it seems like a triangle, but in case of triangle, triangle is a two-dimensional figure and it is three-dimensional body. So in cone, y bar is h by 4, but in centroid case of triangle, in case of triangle, y bar is h by 3. So don't mix this with that. So here it is y bar is equal to h by 4 in the case of cone. Clear? Now we solve the problem of composite bodies for center of gravity. As we have solved different problems of centroid of composite figures, similarly in this case we find the center of gravity of a composite body. So this is the problem. Find the center of gravity of the composite body shown if the height of the cone is 10 centimeter and radius of base is 5 centimeter. So this is the body made by two bodies. One is hemisphere, it is hemisphere, and this is a cone. So height of the cone is 10 centimeter. Height of the cone is 10 centimeter, and the base radius is this. This is the base radius. So this is 5 centimeter. So now we have to find out the center of gravity. So as earlier, first of all, we have to select the reference lines. So this is a figure, this is a body which is symmetric about this reference line. This is y-axis. So it is symmetric about y-axis. So we have not to calculate the x bar because we know the x bar will be equal to 0 as it is symmetric about y-axis. Now we will find y bar. So y bar will be v1 y1 plus v2 y2 upon v1 plus v2 as this is summation vy upon summation v. So we have to decide the body. This is, suppose this is number 1 and this is number 2. This is number 1, this is number 2. Now v1 is volume of the hemisphere. So 2 by 3 pi r cube. So this will be equal to 2 by 3 pi into 5 ka cube. And V2 is cone. So this is equal to 1 by 3 pi r square h, or it will be 1 by 3 pi into r square into h. So this is the volume. So now this will give you the volume. So calculate the volume. So this will be equal to as 2 by 3 pi r cube. So 2 divided by 3 into pi into r cube, 5 ka cube. This will be equal to 261.799. 261.799 centimeter cube. Now this is for cone. So 1/3 into pi into 5 pi square into 10. So this is also equal to 261.799 centimeter cube. Now y1 is the distance of center of gravity of the hemisphere, because one part is hemisphere. So y1 is the distance of center of gravity of hemisphere from this reference line x-axis, from this x-axis. So this is at 3r/8. So 3 into r by 8. This is 3 into r/8, 3r/8. And for y2, it will be at minus h/4, because it is below the x-axis. It is below the x-axis. It will be at the below the x-axis. The center of gravity of this cone is below the x-axis, below this line. So it will be of minus sign. So it is h/4 is equal to minus 10/4, or equal to minus 2.5, and this is equal to y1. Y1 is 3r/8. So this 3r/8 is 3 into 5 divided by 8, equal to 1.875. So now this y bar is equal to v1 y1 plus v2 y2 upon v1 plus v2. So this v1 is, as we have calculated, v1 is 261.799. 261.799 into y1 is 1.875 and plus v2 is also 261.799, and this is y2 is minus 2.5. So it is minus 2.5 divided by v1 is 261.799 plus 261.799. v2 is also. So now we calculate 261, 261, 261, 261. So all the volumes are equal. So these can be cancelled out, and only the value remaining is 875 minus, because this minus will be here, so minus 2.5 upon 1 plus 1, because if we take this value common from the numerator and this value common from the denominator, so both are cancelled out. Here only 1.875 minus 2.5 upon 1 plus 1. This will give you the value 1.875 minus 2.5 divided by 2. So this is minus 0.3125 centimeter. So it is at 0.3125 centimeter minus sign is showing that it is below the x-axis. It is below the x-axis or below the reference line along x-axis. So it is at minus 0.3125. It means it is below this reference line. Below this reference line. So minus sign is below this reference line. So it will be at 0.3125. 0.3125. So it will be here. Okay. Thank you. Now this is a problem of cone from which a cylinder is deducted coaxially. From which the cylinder is cut down coaxially. So this is a cone of height 15 centimeter and the radius of the cone is 5 centimeter. So base radius is 5 centimeter and this height is 15 centimeter. From this cone, a cylinder is cut down coaxially of height 5 centimeter and diameter is 5 centimeter. Height is also 5 centimeter and diameter is also 5 centimeter of the cylinder, and this is cut down coaxially. So first figure is this cone and second is this cylinder. So now x bar will be equal to 0 because it is coaxial. Both are coaxial and symmetric about this y-axis. Symmetric about this y-axis. So this is x bar is equal to 0. And second reference line is this one. So from this reference line, we have to find out y bar. So we have to find out y bar. So now V1 for the cone 1/3 pi r square h, and V2 is for cylinder pi r square h. So here 1/3 pi into 5 the square into height is 15 for cone. 1/3 pi into 5 square radius into cone की height, and for this cylinder pi r square h. So pi and r is for this cylinder is 2.5 because it is 5 centimeter diameter. So r is 2.5. So this is of 2.5 square into height is 5 centimeter of the cylinder. So this is 5 centimeter. Now y1 for cone. So y1 for cone is h/4. So it is at 15/4, and y2 for the cylinder. So it is h/2. So height of the cylinder is 5. So it will be at 5/2. So now calculate these values by the calculator, and this V1 is 1/3 into pi into 5 का square, 5 into 5 into h 15. So this will give you 392.699. 392.699. So this is the volume of the cylinder. Oh, cone. Sorry, cone. This is the volume of the cone. Now for cylinder. So cylinder is pi into 2.5 is the radius square into 5 is the height of the cylinder. So this is 98.174. So now the y1 and y2. So y1 is 15 divided by 4. So this is equal to 3.75 and this is 2.5. So now this summation, so y bar is equal to summation vy upon summation v. So this is v1 y1 minus v2 y2, because v2 is of minus, because v2 is of minus sign, because v2 is of minus sign, because it is deducted from the cone. So minus sign. So v1 minus v2. So on putting the values, 392 is v1.699 into 3.75 minus 98.174 into y2 is 2.5 divided by 392.699 minus v2 is 98.174. So on solving this by the calculator, so 392.699 into 3.75 minus within bracket 98.174 into 2.5 bracket close equal to this much, and divide by bracket 392.699 minus 98.174 bracket closed is equal to 4.167. So y bar is 4.167. So it is at 4.167 from the reference line along x-axis. So it is just below the upper edge of the semicircle. So it is a hole made in this. So the problem of this type can be solved by taking the minus sign with the volume deducted. So it is here y bar is 4.167. This is the answer. Okay, thank you.